the resistance depends on its length. Means length is increases, resistance is increases. And next, we want to increase the resistance. Another step is we want to reduce the area or thickness. When the thickness is decreases, resistance is increases. Why? R proportional to 1 by A. Means to increase the resistance, we must increase the length. Otherwise, to increase the resistance, we should reduce the thickness or area of the wire or conductor or resistor, you take any one. Okay. Anyhow, the resistance must be increased by the two methods. One by increasing the length, another one is decreasing the thickness. Now, without increasing the length, we want to increase the resistance or decrease the resistance. Is it possible? Yes, possible is there. That is the combinations. We have two combinations. One is series combination of resistors and parallel combination of resistors. When the resistors are connected in series, what happened, that we want to discuss now. If the resistors are connected in parallel, what will happen, the resultant resistance, that we want to discuss now. This topic already you are studied in 10th class, but it is in our syllabus. Up to now it is not given in the examination, but anyhow already you are studied in 10th class. That's why I think it is very easy for you. Now, series, what is the meaning of the series means? This is first resistor. This is the symbol for resistor. This is the first end. This is the second end. Second resistor. This is the first end. This is the second end. The second end of any instrument is connected. The second end of any instrument is connected to first end of another instrument. This instrument second end is this. This instrument first end is this. This is called series. Here, this is the resistor 2. This is its second end. This is resistor R3. This is the first end. Means it is called as a series. Series means one resistor second end is connected to another resistor first end. This is called as the series combination. In the series combination of resistor, we take three resistors R1, R2, R3. These three resistors are connected to one source, one battery. This is the symbol for battery. Then the potential difference between the first end of the resistor is V1. The potential difference between the second end of the resistor is V2. The potential difference at the end of the third resistor R3 is V3. So from figure what we can write? V is equal to V1 plus V2 plus V3. Okay. V1 is the potential difference between the ends of the first resistor R1. V2 is the potential difference at the end of the second resistor R2. And V3 is the potential difference at the end of the third resistor R2. So these three resistors connected between the one source. That's why V is equal to V1 plus V2 plus V3. We know the Ohm's law. What is the mathematical expression for Ohm's law? V is equal to IR. Now, potential difference. PD means potential difference at the ends of the first resistor. Potential difference at the ends of the first resistor is V1 is equal to I into R1. In the series combination, current is the same in each resistor. In the series combination, current is the same in each resistor. That's why the potential difference at the end of the first resistor is V1 is equal to IR1. Next, potential difference at the ends of the second resistor. Potential difference at the ends of the second resistor is V2 is equal to IR2. Current is same. Next, potential difference at the end of the third resistor is V3 is equal to IR3. Means in the first resistor, second resistor, third resistor, current is same but potential is not same. Now you substitute V1, V2, V3 in this equation. So what is V? V is equal to IR. What is V1? I into R1. What is V2? I into R2. What is V3? I into R3. Which is common? I is common. I cancel. R is equal to R1 plus R2 plus R3. Means when the resistors are connected in series, the resultant resistance is R is equal to R1 plus R2 plus R3. If you take 3 resistors, you take number of resistors, R is equal to R1 plus R2 plus R3 dash 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 Rn. Okay, when the resistors are connected in series, resultant resistance is increases. Okay, when the resistors are connected in series, resultant resistance what happen? Increases. Under this topic we have one 2 marks question. The resistors are connected in series. What is the current ratio? What is the voltage ratio? When the resistors are connected in series, current ratio is I1 is, I2 is, I3 is equal 1 is to 1 is to 1. Why? The current is same in each and every resistor. You must be remember, in the series current ratio is the same. Current is not changed. That's why I1 is to, I2 is to, I3 is equal 1 is to 1 is to 1. But what is the voltage ratio? Voltage ratio is V1 is to, V2 is to, V3 is equal R1 is to, R2 is to, R3. Okay. These two are very, very important for 2 marks. What is the current ratio? I1 is to, I2 is to, I3 is 1 is to 1 is to 1. And voltage ratio V1 is to, V2 is to, V3 is equal R1 is to, R2 is to, R3 in the series. Is it clear? Next, parallel combination. Now what is the meaning of parallel combination? Here also we take 3 resistors, R1, R2, R3. All the resistors, first end is connected to one point, second is connected to another point. The 3 resistors, first ends are connected to one point, second ends are connected to another point, and in between these 2 points we take one source, means one battery. Now what about the resultant resistance in the parallel combination? Now we want to derive this. When the resistors are connected in parallel, potential difference in first resistor, second resistor, third resistor is same. Potential difference is same in the ends of first resistor, second resistor, third resistor. You take number of resistors, for all resistors voltage is same, potential difference is same in parallel combination. But which is different? Current is different. Which is different? Current. That's why from the battery current here I1 and enters the first resistor as I1, second resistor as I2, third resistor as I3. From the first resistor current is I1, from the second resistor current is I2, from the third resistor current is I3, and these 3 are mixed and become as I. Here I is splits into 3, I1, I2, I3, and these 3 are combined here and become as I. Okay, means in the parallel combination potential difference is same but flow of current is not same, it is different. Okay, from figure what we can write? I is equal to I1 plus I2 plus I3. I is equal to I1 plus I2 plus I3, and we know that Ohm's law. What is the Ohm's law? V is equal to IR. Then I is equal to how much? V by R. I is equal to V by R, and we know that current through the first resistor is I1 is V by R1. Why? Again V I am taken, voltage is same. Next, current through the second resistor is I2 is equal to V by R2. Here also voltage same, but current is different. And current through the third resistor is I3 is equal to V by R3. That's why in parallel combination which is different? Current is different but not potential. Okay, we know I is equal to V by R, I1 is equal to V by R1, I2 is equal to V by R2, I3 is equal to V by R3, and substitute all these in this equation. What is I? I is equal to V by R. That's why I is equal to V by R. And next one, what is I1? I1 is equal to V by R1. This I am taken here. What is I2? I2 is equal to V by R3. From this I am taken. What is I3? V by R3. Which is common in these three? V is common. That's why 1 by R1 plus 1 by R2 plus 1 by R3, V3 cancel. Sir, V cancel. So what is answer? 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. You take 3 resistors. If you take number of resistors, 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3 dash 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 1 by Rn. Okay, when the resistors are connected in parallel, what about the resultant resistance? The resultant resistance is decreases. When the resistors are connected in parallel, resultant resistance what happened? Decreases. Okay, now when the resistors are connected in parallel, again the 2 marks question is, what is the current ratio? What is the voltage ratio? When the resistors are connected in parallel, current ratio is different. What is the current ratio? I1 is to, I2 is to, I3 is equal to 1 by R1 is to, 1 by R2 is to, 1 by R3. When the resistors are connected in parallel, what is the current ratio? I1 is to, I2 is to, I3 is equal to 1 by R1 is to, 1 by R2 is to, 1 by R3. Then what about the potential ratio? Potential ratio is the same. So how we can write it? V1 is equal to, V2 is equal to, V3 is equal to, V1 is to, V2 is to, V3 is equal to how much? 1 is to, 1 is to 1. Okay? In parallel combination, voltage ratio is same. That's why V1 is to, V2 is to, V3 is equal to 1 is to 1 is to 1. Okay? These 2 topics are important, already are studied in 10th class. In series combination, resistance is increases. In parallel combination, resistance is decreases. Both are opposite. In series, resistance increases. Parallel resistance is decreases. In the series, voltage is different. Current is same. Voltage is different. Current is same. But in parallel combination, opposite. Opposite means voltage is same. Current is different. Once again, in series, current is same, but voltage is not same. But in parallel, current is different, but voltage is what happened? Same. Okay.